Welcome to this comprehensive guide on sandbox environments. A sandbox environment is an isolated, controlled space where code and applications run safely without affecting your main system or network. Think of it like a digital sandbox where you can play, test, and experiment without causing any real-world damage. Just as children can build and destroy in a physical sandbox freely, in a digital sandbox, you can run untested code, test new features, or analyze suspicious files safely. Sandbox environments have four main characteristics. First, they provide complete isolation, running independently without interfering with production systems. Second, they use virtualization to create virtual machines or containers that simulate real environments safely. Third, they offer detailed monitoring that tracks all activities, file modifications, and system calls in real time. Finally, they enforce access restrictions that prevent unwanted communication with external systems or unauthorized file access. Sandbox environments are used in several ways. In software development, developers test new code, APIs, and updates safely before releasing them to production. Security professionals use sandboxes to examine suspicious files and malware without risking their systems. Quality assurance teams identify bugs, regressions, and performance issues in controlled settings. Educational programs use sandboxes for training and onboarding users and developers in safe, realistic environments without any risk of causing damage. Sandbox environments provide several important benefits. Enhanced security prevents malware and threats from affecting your production systems and sensitive data. Risk-free testing allows you to experiment with new features and updates without impacting live systems. Cost reduction happens by detecting and fixing issues early, preventing expensive problems after deployment. Threat analysis lets security teams safely analyze malware behavior and zero-day threats without putting systems at risk. Understanding sandbox architecture helps you see how isolation works. The host system contains your main operating system, production data, and critical services. The isolated sandbox is a separate environment using virtual machines, containers, or isolated processes with restricted access. These two systems communicate through controlled channels. Monitoring systems track all activity, logging behavior, and detecting threats. This three-part architecture ensures complete separation while maintaining the ability to observe and analyze what happens inside the sandbox. Sandboxes provide powerful monitoring features. Activity logging records all system calls, file operations, registry changes, and process interactions. Network tracking captures and analyzes all network connections, DNS queries, and data transfers. Behavior analysis detects suspicious patterns, unauthorized access attempts, and malicious actions. Performance metrics measure CPU usage, memory consumption, disk input-output, and resource efficiency. Together, these monitoring capabilities give you complete visibility into everything happening inside the sandbox. Following best practices ensures your sandboxes work effectively. First, mimic production environments closely so your testing results are accurate and realistic. Second, maintain complete isolation between sandboxes and production systems and separate sandboxes from each other. Third, automate your testing to reduce human error and ensure consistent results. Fourth, refresh sandbox data and configurations regularly to reflect real-world scenarios and keep your testing environment relevant. Security is essential when working with sandboxes. Implement strict access control by restricting sandbox access to authorized personnel and using zero-trust authentication mechanisms. Establish clear usage policies that define acceptable use, data classification, and resource consumption limits. Ensure network isolation through strict network segmentation to prevent unauthorized communication with external or production systems. Protect data by using sanitized or synthetic data instead of production data to prevent exposure of sensitive information. Proper maintenance keeps sandboxes running effectively. Perform regular refreshes by periodically refreshing sandbox data and resetting configurations to keep environments relevant and aligned with production. Control costs by monitoring spending, setting budget limits, and implementing automatic cleanup policies to prevent uncontrolled expenses. Manage lifecycle by setting expiration dates on sandboxes and automating decommissioning to free resources. Rotate team members among sandboxes to share knowledge and ensure consistent maintenance practices. Setting up a sandbox involves 3 key steps. First, define your purpose and goals by determining what the sandbox will be used for, whether that is development, testing, or malware analysis, to guide configuration decisions. Second, select your technology stack by choosing appropriate tools such as virtual machines, containers, cloud platforms, or native sandboxing solutions based on your specific requirements. Third, configure and isolate by setting up network isolation, access controls, monitoring tools, and ensuring complete separation from production systems. Several tools help you create and manage sandboxes. Docker is a containerization platform that creates lightweight, consistent, and portable sandboxed environments. Windows Sandbox is a built-in lightweight Windows feature for testing applications and files in an isolated desktop environment. Ansible is a configuration management and automation tool for setting up and managing sandbox environments consistently. Terraform is an infrastructure as code tool for provisioning and managing cloud-based sandbox resources and environments. Let us recap the key points about sandbox environments. Sandboxes provide a safe testing ground where you can experiment with new features and updates without any risk to your production systems. They enhance security by providing complete isolation that prevents malware and threats from affecting your live environment. They are essential for development, offering critical support for software development, security testing, and threat analysis workflows. Understanding sandbox environments is crucial for anyone working in software development, cybersecurity, or system administration.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.